we can understand a little bit more about energy changes in reactions when we understand the energy required and released when we break and make bonds. As a general rule, breaking bonds, right here, requires energy. Now, things that require energy, we say are endothermic. This actually requires heat energy. I remember it because endo sounds like in to me. So a process that is endothermic, it absorbs heat, or you could say it requires heat. So breaking a bond requires energy. Now forming a bond, so making a bond would be another way to say it. You see here it releases energy. And the process of releasing energy is a process that is called exothermic. So I think of exo as exiting, and when something's exothermic, it releases heat. So heat goes out. In endothermic, just remember, heat goes in to the system from the surroundings. And in exothermic, heat goes out. Endothermic, it goes into the system. Exothermic, heat goes out of the system. Now, if we took all the energy that was absorbed when you break bonds and released when you make bonds, if we took that all into account, we'd get something called the heat of reaction. Now, heat of reaction, so this is the energy change in a reaction. And another word that they use for the heat of reaction is enthalpy, or enthalpy change. So if you see this word enthalpy, it's talking about the heat change in the reaction. And the symbol that they use is delta, which is a capital letter, to capital delta in Greek, and then H. So delta H is the representation of the heat of the reaction. So look right here, when we're talking, we can tell something if a reaction is exothermic or endothermic based on delta H. So here's the definition again. Endothermic heat is absorbed. And notice that delta H is a positive value. So for example, just to show you what it would look like, if something's endothermic, it could say delta H equals positive 13 kilocalories, and it would have a positive sign right like that. And that's telling you that that reaction is endothermic. Now exothermic, see right here, our energy is required. Released. I apologize. Energy is released. Then delta H is negative. So if I was exothermic, where energy is released, delta H could equal, and I'm just making up numbers just so you can have an example, could be negative 30 kilocalories. So then I'm not worried about the numbers. The number will vary depending on the reaction, but I want you to understand when they say it has a positive value or a negative value, we're talking about the sign. Now, again, what it means is if something has a positive energy value, it means that energy was absorbed into the system. If it has a negative energy value, it doesn't mean that it's less than zero. That negative energy value means that it was released from the system. Now, when we're talking about bonds, they're not all created equal. And in this course, we're not going to do anything with the calculations. But so you understand, if you look right here, so depending on the bond, things will change. It's a bond, the energy it takes to break a bond is bond dissociation energy. Okay, that's the energy right here, the energy for breaking a covalent bond. And you can look in your textbook, they have some values. And in higher level chemistries, they do calculations with the bond dissociation energies. But what I want you to understand is that bond dissociation energy will depend on the type of bond and what elements are there. And then importantly, right here, that the stronger the bond, the higher or larger the bond dissociation energy. So the stronger the bond is, the more energy it would take to break it. Now there's several things, and we're going to do some problems with this chart, so I want you to kind of take a look at it and pay attention. There's several things that we can classify when we have on this side an endothermic reaction, and then on the other side over here an exothermic reaction. So this side we have endothermic, and this side we have exothermic. So let's look at the bullet points. Okay, so let's look and see the different bullet points. So it says the first one is endothermic, the definition, heat is absorbed. Okay, exothermic, heat is released. Endothermic, delta H, or the heat of reaction, is positive. Exothermic, delta H, is negative. Now here's something we haven't talked about. So look at the endothermic. It says the products are higher in energy than the reactants. Now you might recall from the discussion of energy that in chemistry, the lower the potential energy, the more stable something is. So in an endothermic reaction, because energy is absorbed, so you start with a certain energy level, and I absorb the energy in an endothermic reaction, the products actually end up being higher than the reactants in energy. Compare that to exothermic. So exothermic reactions, the energy is released. So your reactants have some energy, and then they release some. So they aren't going to have as much when they become products, and so the products are lower than energy in the reactants. What it tells us, again, remembering that lower energy is stable. In an endothermic, because the products have more energy than the reactants, it's actually the reactants that are more stable. And so if you look at the last one, it says bonds broken in the reactants are stronger than bonds made in the products. So the reactants are lower in potential energy. And then in the exothermic, it's the opposite. And the one that's the lower in energy, the products, is stronger, that has stronger bonds than the reactants. Let me take a look at that again, those two sentences, and try to put it together. So here we see on the endothermic side that the products are, higher in energy. And then we notice than the reactants, okay? So the ones that are lower, so I'm just going to circle reactants. If the products are higher, these have lower energy. The ones that are in lower energy have the stronger bonds. Now look on the exothermic side, it says products are lower, okay? So in this case, products are lower. And the ones with the lower energy are going to have the stronger bonds. So look here, products are stronger. So the one that is lower in energy, though that category, reactant or product, has the stronger bond. And you can see right here, I wrote it as well. So now let's take a look, and we might have to go back and forth between this chart, but let's take a look at some problems that kind of makes us think through this. So this first question says, do each of the following statements describe an endothermic or an exothermic reaction? Okay, delta H is negative. So looking here, delta H is negative for an exothermic reaction. Letter B. The energy of the reactants is lower than the energy of the products. Okay, so reactants are lower. So looking here, I see in this step right here that in endothermic, the products are higher and the reactants are lower. So that's endothermic. In a future section, we're going to talk about energy diagrams, and this will be an illustration of how you can remember which reactants or products are higher or lower. Letter C, energy is absorbed. That's the definition of endothermic. Energy is absorbed. So if we look here, we can look back. Energy, heat is a very common form of energy in chemistry, is absorbed. And then letter D, the bonds in the products are stronger than the bonds in the reactants. Well, I know they're lower in energy if they're stronger. And I think, the bonds in the products are stronger, which means they are lower in energy. So the bonds in the products are stronger. So that is exothermic. So one of the things you need to do is look at those lists of endothermic and exothermic and be familiar with how we describe them in terms of their definition, delta H, whether reactants or products are higher and lower in energy, and whether the bonds in the reactants and products which one is stronger. So now let's take a look at another question. And this one has a reaction. It says 2NH3 makes N2 and 3,2. And then notice here, it gives us a delta H. And so this question I always like to do in class because it shows you that sometimes it benefits to read through the whole process before you just start answering questions. So it says, is heat absorbed or released? Okay. Which bonds? That's the first one. Which bonds are stronger, those in the reactants or those in the products? C, are the reactants or products lower in energy? And D, is the reaction endothermic or exothermic? So I'll tell you how I think of this one. I look right here and delta H is positive. And so I remember from my definition that delta H being positive is an endothermic reaction. And I'm just going to write here why I think that. Now, then I've memorized that endothermic means heat is released. So then I'm going to answer the second question. Because I answered question D first, I know that question A is heat is absorbed. Let me erase it. I apologize. I was ahead of myself. For endothermic, heat is absorbed. I apologize. You probably were like, what? So endothermic equals heat absorbed. So that's the definition. Now, so what I know in endothermic, I know that the reactants are lower in energy. And I think it through this way. I know that endothermic absorbs energy. So that means the products must be higher because when you absorb energy, you're going to go up. So I know that the reactants are the ones that are lower in energy and endothermic because they absorb energy and go up, so the products are higher. But this wants to know which ones are lower. And then finally, I know the ones that are lower in energy are stronger in bonds. So the reactants have stronger bonds, and I think to myself because I know they are lower in energy. And the ones that are lower in energy, the products or the reactants, have stronger bonds. So I always like thinking through this question with students because I think it's a good illustration of where, for example, an exam or a homework question, if you read through all the questions it's asking you, sometimes you may find an order to answer the questions that helps you think through the answers in a different way. And I like to answer this. For me, I answer D, and then I answer A, and then I answer C, and then I answer B, because it's how I've kind of thought through those answers.